Hello everyone. We have discussed number of things with respect to the root locus. Once again, we will discuss some problems on the root locus. We'll revise the steps for solving the parameters on a root locus. These are the steps. First one is find branch details. Second, plot pole zero plot on S plane. Find real axis loci. Find number of asymptotes and angle. Then next step is find centroid. Next, find breakaway point if any. Step number 7, if any complex pole or zeros are present, find the angle of departure or angle of arrival respectively. Next step, if locus crosses j omega, its imaginary axis, find the value of j omega crossover. And the last, predict the stability of a system. These are the steps for drawing the root locus for a given system. Then we will discuss one or more examples on the root locus. First example, draw root locus plot for unity feedback system having transfer function g of s is equal to k divided by s into bracket s plus 2. G of s is given, g of s is equal to k divided by s into bracket s plus 2. Unity feedback means h of s is equal to 1. We will follow one by one step for that. First step is find the branch details, plotted on a pole 0. Then branch details, it means that you have to find out how many zeros and how many poles are there. For a given transfer function, g of s is equal to k divided by s into bracket s plus 2. Number of zeros are not there, so z is equal to 0, and two poles are there. One is at 0, another one is at a minus 2. Easily we can calculate, easily we can find out of the calculate. Then we will draw the pole 0 plot diagram on S plane. This is the second step. Then one 0 is 0 are not there, only poles are there. One is at a 0, another one is at a minus 2. Therefore third point is a root locus is lies in between minus 2 less than sigma centroid less than 0. It means that root locus is in between 0 to minus 2. Next step, find the number of asymptotes and angles. For that, first you have to know the p minus z is how much. As we know the formula for finding the angle is theta is equal to 2q plus 1 into 180 divided by p minus z. P means number of poles and z means number of zeros. A number of poles are 2, therefore 2 minus 0 is equal to 2. Then we will apply the this data for finding the angle. Theta is how many symptotes are there? 2 symptotes are there, so we will get to 2 angles, theta 0 and the theta 1. For finding that, you have to first put q is equal to 0 and find out the theta. So after putting q is equal to 0 in a formula, theta is equal to 2q plus 1 in bracket 180 divided by p minus z. I'll get 180 divided by 2, so therefore theta 0 is equal to 90 degree. Then we'll find out theta 1. We'll put here q is equal to 1, so 2q means 2 plus 1 into 180 divided by 2 I'll get a theta 1 is equal to 270 degree. Then next step, after finding the number of asymptotes and angle, we'll find out the next centroid. Formula for finding the centroid, centroid is equal to sigma is equal to summation of real part of pole minus summation of real part of zeros divided by p minus z. Here it is, poles are not present, so we'll consider only summation of real part of poles. And the real part of poles are, one pole is at a 0 and another pole is at a minus 2. Therefore 0, as it is algebraic summation, therefore 0 minus 2 divided by 2, therefore minus 2 divided by 2 is equal to minus 1. Therefore centroid is at a minus 1. It means that we will draw the line or asymptotus line which will crosses the root locus at a minus 1, as a centroid is at a minus 1. And then next step is we will calculate the breakaway point. For finding the breakaway point, we have to consider the characteristic equation 1 plus g of s into h of s is equal to 0. As this is a unity feedback system, h of s is given, h of s is a 1 and g of s is a given, k divided by s into bracket s plus 2. We will solve this for equation. Therefore we got the equation s square is equal to 2s plus k is equal to 0. Then solve it for the k is equal to minus s square minus 2s. Then we'll take a derivative of it, dk divided by ds is equal to minus 2s minus 2 is equal to 0. Therefore we got the answer s is equal to minus 1. Here it is s is equal to minus 1 means it lies on the root locus and it is a valid breakaway point. As it is a lies on the root locus is in between 0 to minus 2. Next step number 7 is with respect to if we will get a complex root, we have to find out the breakaway point, angle of arrival and angle of departure. This is not for our example, so we will skip that step. Next step number 8 is we have to find out the intersection with imaginary axis. So again we have to consider the characteristic equation and solve it for the k. As a k is greater than 0, if k will be greater than 0, first column is positive, therefore the system is stable and it will not intersect any imaginary axis. Okay, therefore we will draw the root locus in this way. Here it is, root locus shows the s plane sigma j omega 0 minus 1 and minus 2. Therefore, and we got a two different angle, one is at a 90 degree, another one is at a 270 degree. We'll discuss second example where g of s into h of s is given. G of s into h of s is equal to k divided by s into bracket s plus 5 in another bracket s plus 10. We'll apply the same process or the same steps. The first step is where to find out how many zeros and how many poles are there. First, how many zeros are there? 0. No, not a single zero is present. Number of poles, 3 poles are present. One is at a minus 5, another one is at a 0, and the third one is at a minus 10. And therefore root locus is in between 0 to minus 5 and minus 5 onwards up to the infinity. Therefore two root locuses are loci are present for this example. So root locus is present in between minus 5 less than sigmoid less than the 0 is present. Minus 5 to 10 it is absent, and the minus 10 to infinity it is a present. Then the next step is we have to find out how many asymptotus lines are there and angle for the every line. First of all steps for finding the number of asymptotus lines, that is a p minus z is equal to number of poles are 3, number of zeros are 0, therefore 3 minus 0 is equal to 3. Then we will find out the angle. As 3 asymptotus lines are there, 3 angles will be there, that is theta 0, theta 1, theta 2. Theta 0 you have to find out by putting q is equal to 0, theta 1 you have to find out by putting q is equal to 1, and the theta 2 we have to find out with the help of by putting q is equal to 2. So by putting this theta is q is equal to 0, 1, 2, we got the theta respectively, that is the theta 0 is equal to 60 degree, theta 1 is equal to 180 degree, and the theta 2 is equal to 300 degree. Now the next step is find out the centroid. Here it is, formula is the centroid is equal to summation of real part of pole minus summation of real part of zeros. Then how many poles are there? 3 poles are there. One is at a 0, another one is at a minus 5, third one is at a minus, and you have to take a summation of that. Minus summation of real part of zeros, not a single 0 is present, therefore minus 0 is there. Divided by p minus z, number of poles are 3, number of zeros are 0, therefore 3 minus 0 is a 3. Therefore we got the answer as a minus 5, that is the centroid is at a minus 5. Next we will find out the breakaway point with the same procedure as we have followed for the first example. Find out the characteristic equation. Then characteristic equation is 1 plus g of s into h of s is equal to 0. Put the whatever the g of s and h of s is provided, then solve it for the k. So we'll solve it in this way. 1 plus k divided by s into bracket s plus 5 in another bracket s plus 10 is equal to 0. Then we'll simplify this, s square plus 5s in another bracket s plus 10 plus k is equal to 0. Simplify the brackets, then we got the answer as s cube plus 15s square plus 50s plus k is equal to 0. Then solve for the k. Therefore k is equal to minus s cube minus 15s square minus 50s is equal to 0. Then we'll take a first derivative of the k and we'll equate it is equal to 0 for finding the value of s. Therefore dk divided by ds is equal to minus, we have taken minus sign outside, 3s square plus 30s plus 50 is equal to 0. Then we'll find out the roots with the help of minus b plus minus root over b square minus 4ac divided by 2a, where a, b, c values are there with the, what is a, b, c? A is 3, b is a 30, c is a 50. Then we'll to put it in this equation, we'll get a two roots. S1 is equal to minus 2.11 and S2 is equal to minus 7.88. But only minus 2.11 is a valid breakaway point because it is lies on the root locus, while another minus 7.88 is not a valid because minus 7.88, wherever the minus 7.88 point is there, root locus or the root loci is not present, as we are written here. In between minus 5 to minus 10 root locus is absent, therefore that is not valid breakaway point. Then 7th number step, as if the imaginary axis is imaginary or the complex roots are present, we have to find out the angle of arrival and the angle of departure. For this example also imaginary roots are not present, so when this step is not for this example. The next step is we'll find out the intersection with the imaginary axis. Here we are going to use the root array characteristic equation. We are having s cube plus 15s square plus 50s plus k is equal to 0. Then we have to simplify this if k is greater than 0, and another one is a 750 minus k divided by 15 greater than 0. Solve for the k, therefore k is equal to 750. Then we'll consider the auxiliary equation for finding the value of the s. We'll get a value of the s in this way, 15s square plus k is equal to 0. We'll put the value of the k as a 750 and solve it for the s. Therefore s square is equal to minus 75 divided by 15, it is minus 50. S square is equal to minus 50, therefore s is equal to plus minus j 7.07. Then finally we'll draw the diagram. As we have find out the number of unknowns. First one is we have to draw the S plane. Then root locus or the RL is present in between 0 to minus 5 and the minus 10 onwards. Then we are having three different angles. 60 degree. Here it is as dotted line shows. For the 60 degree we have to draw one dotted line, and the second one is 180 degree. Again for the 180 degree already line is there. Third one is a 300 degree. We have to draw the line for the 300 degree. Then we got the minus 2.11 as a breakaway point. Then mark that point 2.11 and we have find out the intersection of the imaginary axis, that is at 7.07. Mark that 7.07 on this imaginary line, that is a j omega, and draw the curve which will crosses the j 7.07 positive as well as a negative from minus 2.11. This is a root locus sketch for the given diagram. This is second example. We'll go for a third example. Here it is also g of s is given, k divided by s into bracket s plus 3 and s plus 5, h of s is 1. Same procedure will follow. Number of zeros are 0, number of poles are 3, one is at a 0, minus 3 and a minus 5. Then we'll plot it. We have to plot it 0 to minus 3, that is a root locus. Then from the minus 5 onwards up to the imaginary, up to the infinity, that is a root locus. Then we'll find out the number of asymptotus lines and angles. Number of asymptotus lines are 3. Therefore with the help of formula 2q plus 1 into 180 divided by p minus z, we'll find out the angles theta 0, theta 1 and the theta 2. Respectively we'll get 60 degree, 180 degree and 300 degree. Then we'll find out the centroid. Formula for the centroid is summation of real part minus summation of the imaginary part divided by p minus z. real only poles are present, zeros are not there, therefore 0, one is at present as a 0, another one is at -3, another one is at a -5, divided by p minus z is 3 is equal to minus z divided by 3, therefore centroid is at a minus 2.66. Next step, we'll find out the breakaway point. Same procedure. Consider the characteristic equation 1 plus g of s into h of s. Then put the whatever the g of s into h of s is provided for you. Simplify it for the k. After simplification, you'll get a k is equal to minus s cube minus 8s square minus 15s. Then take a first derivative and equate it is equal to 0. Then we'll get the equation as a minus 3s square plus 16s plus 15 bracket complete is equal to 0. Then here it is, with the help of the finding the roots equations, roots of the particular characteristic equation, use the formula minus b plus minus root over b square minus 4ac divided by 2a. Then put the values, then we'll get answer minus 16 plus 10 divided by 6 and minus 16 minus 10 divided by 6, you will get a 2 breakaway point. One is at minus 1.21, another one is at a minus 4.11. Out of these two roots, only one breakaway point is valid, that is at minus 1.21. Why it is valid only? Because root locus is present in between only 0 to minus 3 and minus 5 onwards. In between minus 3 to minus 5, root locus or the root loci, real root loci is not present. Therefore, minus 4.11 is not a valid breakaway point. Next step, 7 number is not present, as we will not get any complex roots. Next, we'll find out the intersection with imaginary axis. Same procedure we have to follow. We have to use the root array. Equation is s cube plus 8s square plus 15s plus k. Simplify this with the help of root array. 120 minus k divided by 8 is equal to 0. Therefore, k is equal to 120. Take an auxiliary equation, 8s square plus k is equal to 0. Put a value of the k, we'll get a intersection of imaginary axis, s is equal to plus minus j 3.87. We'll get a frequency of oscillations also, s is equal to plus minus j omega is equal to 3.87 radian per second. Finally, we will draw the root locus. Which will consist of all the unknowns. First one is number of poles, number of zeros. Number of poles are, one is at a 0, another one is a minus 3, another one is at a minus 5. Then next one is we have to draw the angles. 60 degree one angle, 180 degree one angle, third one is 300 degree one angle. Then draw the lines accordingly. 3 lines will be there. One is for 60 degree, another one is a 180 degree, is already there, it's on the real axis. The third one is for a 300 degree. Then mark the breakaway point. One is at minus 1.21, which will intersect the imaginary axis at plus minus j 3.87. it is shown by the curved line. And another one line is there, breakaway point at we have to draw the angle from breakaway point at is a minus 2.66. We'll check. Centroid minus 2.60. Whichever angles we are going to draw, you have to draw the angle from whatever the sigmoid we got, that is a minus 2.6. From that point you have to draw the angle, that is a 60, 180 and a 300 degree.